In this video, we are going to explore the use of R and the dplyr package specifically for manipulating data. We're going to see how we can tidy and wrangle a dataset so that it's ready for us to analyze. First, a few words about this particular dataset. Now, we are presented with a scenario where a wealth management company has provided us with information about 3,000 males in the United States. The company wants to determine if there are patterns or trends related to daily wage and demographic variables, such as age, educational qualification, or marital status. Now, the insights will help the company make informed decisions to provide tailored financial solutions to these individuals. For example, if we find that unmarried males with a college level of education tend to earn a higher wage after the age of 30, the company can choose to target current clients who fit this description once they cross the age of 30 to send requests to reevaluate their financial solutions based on available financial schemes. But of course, before we begin our analysis, we need to ensure that the data are clean and well organized. Let's begin by getting the data into RStudio. So the file wages.csv, if I click on it, notice that I can choose to view the file before I import it into R. So here in the raw data in the first row, you can see what the different variables are: age, sex, marital, and so on. Now, I'm going to create a new R script. So here, file, new file, R script. I can close wages now because I don't need it. Now, notice something. This is my source pane on the top left with my new R script, which I'm going to create and save. And I've got the console on the right here. Now, in your version of RStudio, I imagine that you probably have the console underneath the source pane. So this is personal preference, and you can change it in the View menu with View panes console on right instead of on left. Now, the reason why I do this is because most of the time we spend in RStudio, we're either building a script or we're executing code, meaning that we're either in the source pane or the console pane. So I prefer to have them side by side to maximize the amount of space I have on the screen to work with. So let's import this file. Before we do that, let's load the tidyverse, which includes the dplyr package that we're going to use for analysis here. Now, any code I want to be able to execute again, or I want to save, I'm going to put in the source pane. In fact, here I can save this script. And one thing that you should do, which is a good habit to get into, is to create a working directory. So here you can see that this directory is called Career Accelerator Course 3. I've navigated to it in the file pane. And what I'm going to do is, here under More, I'm going to set this as my working directory. So R knows that anything I want to save should be saved there by default, or any data I want to load in, it should look here, okay? And in fact, before I add anything more to my script, I'm going to save this, okay? So see that it looks in the Career Accelerator. I'm going to call this wages script.r. The extension .r tells it that this is an R script. Okay, now, if I want to run something from the source, here on the left, I can do this with a shortcut Control-Enter. So Control-Enter sends the current line, where the cursor is, to the console, okay? So the first thing we want to do is to load this file, this wages.csv. Now, you know that you can do this using the read CSV command. So here I want to load wages.csv. You may have seen that you can also do this with something like read.csv and then file.choose. And the file.choose command is going to bring up a window where you can navigate to this file, double click on it to open it, and so on. But here, if I want to save the script, if I want to remember what I did, it's a lot more convenient to name the file I want to load. How is R going to know where this file lives? Well, it's going to look in the working directory, which is why it's important to set the working directory to where the file is. Okay, so here I'm also going to set header equals true. And the reason for this is that, as we saw when we looked at the raw data, the first row is a header row. So it consists of the names of the different variables. Let's give this a name. Let's call it wages. Control-Enter to send it to the console. So now we have this file in our data. So let's explore it a little bit. So I'm going to move over to the console to do this. What can we do to take a look at what we have? Well, you know that you can do a head of wages. This is going to show us the top, the first few rows of this data frame. So you can see the variables for X, you can see the variables, sorry, for age, sex, marital, race, education, and so on. Okay? As.tibble converts this data frame into a tibble, which is kind of like a data frame in the tidyverse, but also one which displays in a nicer way on the screen. So here you can see, sorry, this is wages, not wage. So here you get a little bit more information. So it tells you, for example, how many rows and how many columns you have. So here there are 3,000 rows, each one corresponding to one individual, and 10 columns corresponding to each one of these variables. Okay? It also tells you a few things about the type of each one of these variables, if you look underneath its name. Now, you may notice here a couple of things that have gone wrong when we imported this file. Have a think about what these may be. You've also come across the glimpse command, so glimpse of wages. Again, it displays it in a slightly different way, but again, it gives us some information on the rows and the columns of this data frame, the different variables, and what the type of each one of these is. Okay, so notice something. If I do a summary of this data frame, what do we see? Well, firstly, something is going on with this age variable. So here you can see that even though this consists of numbers, 18, 24, 45, and so on, the age of each one of these males, R sees it as a character. So there must be some reason why this happened. There must be some reason why this was imported as a character variable, and we need to explore that further. Also, notice something else. The race variable, which if we look at the accompanying information for this data set, we can see that I think 1 corresponds to white, 2 corresponds to black, 3 to Asian, and so on, these different categories. This appears as a number, as an integer, which means that when we ask it to produce a summary of this data set, it computed a mean and a median, and so on. But these numbers, these numerical summaries, don't make sense, because these numbers here are not numbers in any real sense, 1, 2, 3, 4. They're just categories. So we need to tell R that this is a categorical variable. Even though it looks like a number, it's actually a categorical variable, which R calls a factor variable. Okay? Now, these are the obvious issues that we need to fix in this data set. Also notice something else, that because these are all males, it appears that column 2, wages, column sex, is always male. So we might want to check if that is indeed the case and maybe get rid of it, because it doesn't really tell us anything if it only contains one value. And similarly, region always seems to be Middle Atlantic. Now we can verify that quite easily. How? Well, the table command is very useful, because table produces a frequency table of a variable. So here if I do table of wages, then $sex to pick out that column, notice that this is always male. So this frequency table is 3,000 values of male. And similarly, table of wages and region always brings up Middle Atlantic. So we might want to get rid of these two. In fact, you can put a little note here, a little comment to say, get rid of sex and region. Okay, just a little reminder as to what we want to do here. Also, notice that we want to check why age is not numeric. Okay, something's gone wrong there. And also convert race to factor, i.e. categorical. So these are the different things we want to do, and it's useful to add these comments for yourself in the script. Okay, so let's start working through these one by one. Now, we want to get rid of sex and region. So here you might be tempted to do something like wages and then pick out the columns you want, or you could even say something like -2 to get rid of column number 2. Now, I would very, very strongly advise against this sort of thing. Against the sort of thing that programmers call magic numbers. So someone reading this script or even you yourself reading this script a few days or weeks from now, would not remember why you wanted to pick out number 2. There's no indication here. Whereas if you refer to this variable by name, it's clear what you're doing. You're getting rid of the column corresponding to the variable sex and the variable corresponding to the column corresponding to the variable region. Okay? There are lots of different ways you can do this in R. We want to use the dplyr functions to demonstrate them. So I'm going to use select here. So select wages, and here I want to tell it to get rid of the column sex, so minus sex, comma, minus region. That will get rid of these two, okay? So I can create a new data frame here, which I could call wages 2, whatever you like, or I could overwrite the initial one. So here, because I'm still playing around with the data and I want to make sure that this worked properly, I'm going to give this a different name, okay? So let's do that, Control Enter, and let's check that this worked. So head of wages 2, and you can see that you got rid of the 2 columns that we didn't want, that don't add any information. Okay, so next, let's convert race to a factor variable. So the easiest way to do this is using the mutate function. So the mutate function in dplyr is what you use in a data set, in a data frame rather, if you want to create new variables from the existing ones. Okay, so here I want to say that race factor, if I want to create it as a new variable, or even I can just call it race if I want to overwrite the existing one, is equal to what? I'm going to say take as.factor of the existing race variable. Okay? I can create a new data frame here, wages 3, if I want to, and let's do this and let's see that it worked. So here in my wages 3, if I do a summary, or if I convert it to a tibble to see what's going on, you can see that now the race variable appears as a factor. So under race, you can see FCT, which is an abbreviation of factor. And we can confirm this because if we do a summary, it's no longer going to try to compute a mean or a median or do anything that doesn't make sense with these numbers. Instead, it produces a little table. You can see under race, 1, 2, 3, 4, how many men are in each one of these different categories. Okay, so we got rid of sex and region, which we didn't want. Now, let's work on this trickier one. Let's figure out why age is not a numeric variable. So the first thing we can do here is we can create a new data set. So again, I'm going to mutate the previous one, wages 3. And I'm going to create a new variable. I'm not going to overwrite the existing one, just in case anything goes wrong. Okay, so I'm going to call it age num, for example. And this is as.numeric of age. So let's see what happens when I do that. Notice a warning message that R brought up. It's saying, problem when computing age num equals as numeric of age. NAs introduced by coercion. So coercion here means that I forced I forced R to turn this string variable into a numeric variable. I coerced it into a numeric variable, and R is telling me that it tried to do that. It's a warning message rather than an error message, so it did create this variable, but something went wrong, which is it introduced some NA variables. It introduced some NA values. NA stands for not available, and it means that some of these entries in the first column could not be interpreted as numbers by R. It couldn't coerce them to numbers. And if I do a summary, I don't need to do a summary of the whole data frame here. I can just look at age num. You can see that there is one NA value, okay? Of course, at this point, we could just get rid of that row. We could say something went wrong here, some person's age is not encoded as a numeric variable, so we could just delete that row, okay? If that's what we wanted to do, then we can do that using the filter function. So filter is a function in dplyr which allows us to keep certain rows of a data frame based on a particular condition. So here I could say that wages 5, I want to filter my data frame, which is wages 4. And which ones do I want to keep? I want to keep the ones where age num is not NA. Okay, so is NA, age num. Okay, and I'm going to put an exclamation mark which negates this. Okay, so this says from wages 4, keep all of those rows where age num is not NA. So I could do that. So here, how many rows do we expect this to have? Wages 5. Well, we expect it to have one fewer than wages 4. And we can double check that. We can look at the dimensions, for example, of wages 5. You can see that it now has 2,999 rows. But could we do better here? Could we do better than just deleting this row? Well, let's take a look at what went wrong. Okay, so here, I'm going to copy this filter command. And I'm going to take a look at the row where age num is NA. So let's see what happened. Now notice here, under age, it looks like age is 50, but actually that's not a 0, that's the letter O. Okay, so instead of 50, this was written down as 50. So here, we can be fairly confident that this was just a typo, that this is a person whose age is 50. Okay, so we could insert this number here in age num. We could correct this data set rather than get rid of the row. So deleting that row would have been a valid option, but here this is an easy error to fix. So let's fix it. How are we going to do it? Well, we could do it a number of different ways. We could insert it, we could say find which wages for age num equals rather which age num is NA. And this tells us that this is row 44. Okay, so now if I say that wages for age num, this one. So what am I doing here? I'm telling it from wages for the variable age num, pick out the one which is NA, and insert the value 50. So we could do it like that. So now, if I look at a summary of wages for and the numeric age variable, we can see that we're back to not having any NAs here. We have 3,000 numeric values. So we fixed this issue with a data set, okay? And I'm going to comment this one out. And I'm going to add a little note here, which is correcting the value 50 to 50. Okay? Now at this point, we fixed the obvious issues with this data set. So we got rid of redundant variables. We converted the categorical variable that was appearing incorrectly as a numeric variable back to a factor. We also fixed the numeric variable age that was appearing incorrectly as a character variable because of a typo in one of the values. But there is another issue with this data set which is a little bit less obvious. You may have spotted it from the various summaries we did of the data set. So take a look at the summary here. Let's do it again, if you like, of wages for, which is the point we've reached. And take a look in particular at this height variable, okay? So what are the units of this? Well, if you want to explore it a little bit, you could plot a histogram. So here, if I do plot hist of wages for height, we can see what's happening. Now, the reason why this looks a bit suspicious is that the values we get at the beginning are quite low, 73, 70, 69, 67, and so on, which would suggest height in inches, right? But here, you can see that there are values that go up as high as 199. In fact, the third quartile is 167, which doesn't really make sense. So let's plot a histogram so we can see what's going on here. Now, notice that the data fall into very different groups. In fact, we can see quite easily here that what's going on is that some of the data are encoded, some of the height measurements are in inches, whereas others are in centimeters. The ones on the left in the histogram are in inches, the ones on the right are in centimeters. Now, this is an issue that can arise when your data set is made up of data from different sources. Maybe different conventions were used when recording the data. And this is something that we're going to have to fix here as well for our data set to be clean. Okay, so how are we going to do it? Well, one thing we can do here is to separate the part of the data set where height is encoded incorrectly. So here at the beginning, at the top of the data set, we've got height in inches, so let's assume that that's what we want to keep. Okay, in fact here you can see that if you do a head of wages for height, sorry, I misspelled, wages for height, you can see that these are all integer values. Okay, so we want to convert these to inches, integer. How are we going to do that? Well, there are a number of different ways. One of them is to separate the part of the data set where height is encoded incorrectly. Okay, so I'm going to call this, again, it helps to give it a name that is somewhat memorable. So before I was just incrementing wages, wages 2, wages 3, wages 4, and so on, which is not particularly useful. But of course, if it was just simple, quick operations like changing something into a factor variable or changing something to a numeric, we didn't need to do anything much more sophisticated. But here, I'm going to call this wages CM. So which values are wages CM? I want to filter because I want to take part of this wages data set. And I'm going to have to set some sort of arbitrary cutoff value here. Okay, so I can do this anywhere that seems sensible. So here I could say, for example, that a cutoff point could be somewhere around 100 or 120. So basically, any numerical measurement below that, I'm going to treat it as being in inches, and anything above that, I'm going to treat it as being in centimeters. Okay? So here, I'm going to say filter the part of the data set where height is greater than, let's say, 100. So now I've got my wages CM. Let's take a quick look at a summary of wages CM height. Okay, now this seems to have worked in that the lowest value we have is 155, which is plausible height in centimeters, and so on. So these all look like centimeter values. What do I want to do with my wages CM? Well, I want to mutate it, and I want to say that height, here I'm going to overwrite the height variable. What should this be equal to? I want to convert from centimeters to inches, so I'm going to divide by 2.54, okay? And in fact, if I want to be consistent with the rest of the data where these were integer values, I'm going to round this. So round height over 254. Let's try that and see what happens. So summary of wages CM height, and now we've got these values which are in inches. So the final step here is to combine the part of the data set where height is in inches with the part where it is in centimeters. Okay, so here I'm going to say convert centimeters to inches. Okay, and here I want to combine the two data sets. Okay, which two data sets? Well, I want to combine the part that is in inches. Now I can define this. I can say that wages inches is filter of wages for where height is less than or equal to 100. Okay, so I could do it this way. And finally, my wages, I'm going to call it wages clean because this is the final data set that I'm going to save. I can say that wages clean, I want to combine these two. Okay, so I can do this using rbind wages inches and wages CM. Okay, so let's do this, and let's take one final look at this wages clean to make sure that it has the right dimension. So in fact, you can even see that at the bottom left on the environment pane. You can see that wages CM has 856 observations, rows that is, wages inches 2144, put them together and you're back to 3000 observations. So now if I were to do a summary of wages clean, the other variables haven't changed, but now height goes from 60 to 79. Those are the minimum and the maximum values, so it all seems a lot more sensible and a lot cleaner. We're going to finish by saving this data set, which we're going to do with the write.csv function. So write.csv, the first argument is the object you want to save, typically a data frame. So this is my wages clean. Next, I need to give the file I'm going to save to a name. So I'm going to call this wages underscore clean. And if I save this, where is R going to save it to? Well, it's going to save it to the working directory that we defined at the beginning. So here, you can see that we now have a new CSV file, wages clean. We can take a look at it if you like, and this contains the new variables, the clean data. Finally, I'm going to save my script here, or with Control S, and now we're done. We're ready to analyze the data. We've got a clean data set that we can use for further analysis.